the fellow faculty members and the research scholar. Is my screen visible?
Yes, sir, it's visible.
Yes, sir.
Yes, sir.
Okay, fine. Thank you. So, in next 1.5 hours, I will be discussing more about what exploratory data analysis is all about. Right? In computer engineering, most of the time we talk about the fancy thing like recurrent or reinforcement learning or the advancements in the deep learning. But many a time, right? What I observe that the basic informations when we ask to the faculty or to the scholars, right? They have not understood that in proper way. So what I will do is I will focus on the basics of what data analysis is all about, because the topic or the title or the theme for this FDP is advancements in data science and machine learning. So what I will do is I will be discussing about exploratory data analysis, then the classical machine learning algorithms, and where to use these algorithms once you have the understanding about the data. So data understanding is very important. We should not apply unnecessarily the techniques or the algorithms which are computationally very heavy. If the required task is being done with the simple machine learning algorithm, then we should not invest time and memory for the algorithms, right, which are having multiple layers and all. So with this, I will start my talk. So when the first top point is, I think the first slide is visible to all, right? Hello.
Not visible yet.
Yes, sir.
Yes, it is visible.
Okay, fine. So when we say that, just a minute. Just a minute, I just have to change the view so that it is. Anyway, it's fine, sure. So just a minute. Actually, I need to change it a bit. Just a minute. Now is it visible?
Yes, sir.
Yes,
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 sir.
it is visible.
Yeah, good, fine. So the first thing is, before I jump start onto the topic on which I will be discussing, right? Why we are discussing all about data nowadays? We were not discussing about the data and data analytics 20 years ahead, but when it is beginning of 21st century. There are reasons to that, because you must be aware about the industry 4.0, right? So when we say industry 4.0 or any industry, we must have to study the evolution of these or the history of these various industrial revolution. So as you can see over here, see, in most of my presentation I keep this slide because this is very relevant slide for any talk. Right, as you can see over here, the first industrial revolution was there, it was called Industry 1.0, and it was started around not exactly at 1784, but the mean year has been mentioned. So it was started in late 1800s. So 1784, it was started, and basically the focus was on mechanization and steam power, the introduction of steam engine and all. It took almost 100 years, as you can see, from 1784 to 1870. So almost 90 years it took to shift from Industry 1.0 to Industry 2.0, where the assembly lines were introduced. Instead of steam power, the electrical energy were used, and then the mass production or the assembly line systems were introduced. So that increases the manufacturing capability. So as you can see over here, the first this approach was started by Henry Ford. So Henry Ford has introduced the concept of assembly line production. So at 1870, the industrial revolution 2.0 or industry 2.0 was introduced. Then almost 100 years. As you can see over here, it took more years to shift or transform from industry 2.0 to 3.0, where we started discussion about automation, computers, and electronics. It took almost 100 years, even more than the time taken to transit from 1.0 to 2.0. The reason behind that was that during the tenure of 1870 to 1969, right, the world has faced two world wars, right, and couple of civil wars as well. And the COVID-like pandemic was there in the year 1918, 1990. So, because even though all these calamities were there were lots of civil unrest in some parts or most part of the world. Even though the researchers and scientists were working on finding out solutions that will make in humans' life easier. So, in 1969, the industrial or industry 3.0 was introduced. So when people have started discussion on computing, people have started discussion on automations. Now, right now, when we talk about industry 4.0, we basically talk about different types of networks, whether it is a mobile ad hoc network, whether it is a sensor network. So because of these network and internetworking of devices, there are certain issues related to privacy and the security. So side by side, we have started discussion on cyber systems and Internet of Things. So all these are very much connected, right, with one another. So right now we are talking about Industry 4.0, which was started in the first decade of 21st century. So by 2035, right after 10 years, we are assuming that we will be shifting from Industry 4.0 to Industry 5.0. So we are not supposed to study only Industry 4.0, but we have to be ready for Industry 5.0. And that is the reason that government is giving lots of emphasis for everyone to understand the importance of artificial intelligence and the algorithms and the applications, how we should have these use of AI, right, which will help to uh, make the individual's life easier. So going forward after 10 years, we will be seeing that the self-optimization in the sense that machine will optimize on its own without even human intervention. And AI will take lots of most of the applications will be there in through AI. We have started discussions on agentic AI. Nowadays, the prompt engineering is another such area wherein the application level, those who are working into the applications, they have started discussion and development on this front as well. So obviously, the discussion is in and around artificial intelligence. And it is not about the theory only. What are the practicality of all these concepts in various domains and in various applications that will at the end help the human beings? So that is what we have to keep in mind, and that is the reason that everywhere we are discussing about artificial intelligence, and the as and when the horizon of these artificial intelligence and and its applications will be increasing, that we have to think about individuals' privacy and security as well. So the another most important aspect wherein we will have to think about is the security. So these two technologies or these two domains will be flourish even more in years to come. That is the application or real world or the use of artificial intelligence in the real world applications, and on the same way the 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 robust and secure platform to provide these kind of services. So that this is what the main crux behind uh, the government's emphasis on uh, educate the people for artificial intelligence. Now, why we have started discussion about artificial intelligence and machine learning, and more commonly about the data science. The heart of all this is the input data. Earlier, we did not have enough data available with us. And even if the data was available, it was available into a personal computer. It was not available over internet for free access. Because of the availability of different social media platforms and such public domains. So nowadays the data is available and that data will be used for analysis purpose. Now today I will be discussing about the analyzing the data, and that is the exploratory data analysis. Now this another is the another slide, as you can see over here, that 100 million customers. Now, this is another important thing that one should understand, that how fast the technology is moving. In those who are in the telecommunication domain, they must know that the in telecommunication industry, one generation is nothing but 5 to 6 years. Generally, the generation is considered as the 100 years as a generation. But when we talk about telecommunication industry, the shifting from 4G to 5G took 5 years. Now you just imagine that again the shifting from 5G to 6G will take less than 5 to 6 years. So the one generation lifespan is 5 years in telecommunication industry at this point in time. Now when we say the 100 million customers, am I audible? Hello.
Yes, sir.
Yes, sir, you are
Yeah,
audible.
yeah,
Yes, sir.
yeah. Thank
Yes,
you.
sir.
So I'll
Yes, sir.
intermittently I will ask this question so that at least I should know that the people are there on the other side as well. Okay. So, 100 million customers. So, how much time it took to reach to the 100 million customer? Again, see, these numbers are very, very important. It is not about something fancy or something that you should that there is a reason to that, and you have to deep down into it and think about it. That that when we talk about telephone, this is wired telephone. So it took 75 years to reach to 100 million customers. So it means that 100 million customers got the telephone lines right in 75 years, right from the first telephone to the 100 millionth customers telephone. So it took 75 years to connect 100 million customers over on phones. Now, because of these telecommunication and all, later on people have thought of that can we have any other mechanism by which people can share the information, and that to the public. So World Wide Web was introduced around 85-90, and to reach 200 million customers, the World Wide Web took 7 years. Now you can see over here the underlying hardware infrastructure. Earlier it was wired connections were given, right, and only cell, not this kind of graphic interface was provided. You just have the internet telephony, or you just have some basic internet connections were there when the bandwidth was very, very low. So it took 7 years to reach 200 million customers. Now you just imagine the power of internet. Once the internet was there and it reaches to 100 million customers, now you can see the applications that connect the customers. So Facebook took only 4 years to reach to 100 million customers, and these are all legitimate numbers, right, from the authenticate sources I have taken. So number of years may be approximate, but it took 4 years for Facebook to reach to 100 million customers. It means 100 million active users were there, right, with Facebook, and within 4 years. Now you see this, that now because of internet, because of world wide web, now the applications which requires these the underlying technology, because the internet is essential for Facebook to grow, and at the same time the bandwidth also. Now Facebook took 4 years to reach 200 million customers. Now, going forward, even the application like or the other social media platform like Instagram took 2 years to reach 200 million customers. You just imagine that a simple telephone took 75 years to reach to the 100 million customers, and the application like Instagram took 2 years to reach to the 100 million customers. This is what the power of internet. And why I have been talking about all this, because these are the sources of data, right, which are being used for the analysis purpose. Then, because individuals data is not available over public domain, but these informations are there on public domain, anyone can access and can analyze the data, whether the data is in text form or in the category or numerical form. Then even if we talk about the games or applications, the game like Candy Crush took 6 months to reach to the 100 million customers. It means that these many mobile users have downloaded these game, right, in just 6 months of its introduction. And then the another game, right, which took 2.5 months to reach to the 100 million customers. Now these are simple numbers, but as you can see over here how drastically the world or the world is being connected. And then when we talk about chat gpt, it took only 2 months to reach 200 million customers. Now once it is available, this is what the first 100 million customers. Nowadays billions of users are using chat gpt or any of the generative ai models. So this is very, very important. When we talk about the history of artificial intelligence, till the time initially when Turing test was there, many of you must have studied the theory of computation. The AI and machine learning, those who want to study that in detail, right, they should have the concept clear for the subject like theory of computation. So it was initially the concept was started, and all these were there in the laboratory. When we talk about 1915 1956, there was no real application per se. It was just the concept which was there in theory or maybe in laboratory. It was not there for the public use. So till 1980 we were not aware about, or a common people were not aware about what is artificial intelligence or what is expert systems. Scientists and researchers have started working on it, but those applications were limited and they were on the laboratory or inside the laboratory. And after that, the another 20 years, these applications, development of applications were started. So we started discussion on machine learning, deep learning. And going forward from 2020, when the generative pre-trained model or chat GPT-3 was introduced, right? As you can see over here, that from there onwards, we have started discussion on artificial intelligence for day-to-day applications or the importance of AI in commercial applications as well. And as you can see in 2025, the rise of multimodal and agentic AI. So as you can see over the journey of artificial intelligence, earlier it was there for almost 30 years inside the laboratory. Then it was embedded into some of the applications which were critical applications. And after that, now it has been commercialized. And for in a small application also, these concept of AI and the related technologies are being used extensively. So these figure, I think all of you are aware about. The Venn diagram clearly suggests you that AI is the the broad domain, wherein we have machine learning, deep learning, and generative AI. All of you are aware about what is AI, what is machine learning, deep learning, or generative AI. But before I, so what I have planned is I will swiftly move from this topic to data and then to different machine learning algorithms, which algorithm is used under which condition. It is not like that someone has used X algorithm. So being a researcher or a PhD scholar, I will use Y algorithm and compare them. Or if someone has used X algorithm, I will use the combination of Y and Z, and then hopefully I will get better answer. It is that hopefully will not work, right? You should have clear rationale behind it, that why I should use the combination of two algorithms or hybrid algorithms, right, or boosting mechanism to whether it should improve the performance or not. So that knowledge you should have beforehand. It should not be like you have the data set available and you experiment with different models, and for one particular model if it gives desirable output, then you will fix with that or you will continue with that. What if data changes? You should not select your algorithm based on data, but you should select your algorithm based on based on the data description, not only data. So that I will discuss later on. So now as you can see over here, three numbers are there, 1, 3 and 4. Now I have a simple question. What will be the next number? What will be the next number? Anyone? Hello?
6, sir.
6. So now if someone has said 6, any other?
7.
7. So as you can see over here, I have given you only three numbers and I got two different answers. If you think even in deep, then you may have different answer as well.
Sir, I think it's 5.
Someone is again 5. So if I say that first 1 is there, then I add 2 into it. So the number is 3. Then I add 1 into it. So the number is 4. Now I should add 0. So next will be 4. So I have that logic also. Going forward, I'll get get negative number also. If someone is saying 6, logic is correct. He must be having some logic in mind that why 6, why 7, why 5. Right?
Yes, sir.
Okay. Now, what if I will give you these numbers? What will be the next number now? What will be the next number?
What?
Yeah.
1.
Now
1,
you
sir.
are now you are confident, and most of you are saying that answer is 1. What is the difference between first question and the second question?
Sir, we can see a pattern in case of the second question, sir.
So in case of this, so here also you have a pattern. In first also the answer was
Yes.
based on the pattern only. Then what is
Sufficient.
the
Yes,
Extra
sir.
difference
There is
between
example
no.
or extra example or predict means we have something to test.
yeah, so you have something to taste. The quantum of data that is available to take decision is more, right? Right. So initially you have only
Yes.
three numbers.
Right,
Now
sir.
you have 6 numbers.
Yes,
Okay.
sir.
So this is called machine learning. So predictions are one of the things that machine learning is particularly good at. So if your model is trained with good amount of numbers, good amount of data, right, then if proper model is being used, then obviously you are going to get good result or good accuracy force. Now, what if I will give you these many numbers? Is there any difference in these series of the data points that I have given? Any observation that you can make?
Yes, 314 is there.
Yes, sir.
So for first and the second case, the data set is being used to predict something, right? Here also I have given you the series of 134. Now what you can observe in these series?
There is a one difference. There is a 141 is there.
So as you can see over here, right, this is not matching the pattern. The series of 134 or a triplet is being repeated. But here after 134, we have 314. And again continue 134, 134. Now what does it mean? What are the applications of it in machine learning? What these indicates?
It may indicate outlier.
Yeah, so these are outliers. So what are the applications of outliers in machine learning? Outliers in machine learning. Now this is extensively used.
Anomaly detection.
Yeah, so to find anomaly detection. So anomaly detection, DNA sequencing, disease prediction, cyber security. This is what the simplest way by which you can explain everyone that this is called anomaly detection. Anomaly detection may be change in the DNA pattern. That may be the result of any laboratory test which is against the most of the patient's data. So this is what machine learning is all about. In nutshell, machine learning requires large amount of valid data points. Okay, so this is what machine learning is all. When we talk about deep learning, why I've been discussing machine learning and deep learning? If your task is being handled properly by machine learning algorithm, you are not supposed to go with deep learning. Because as you can see over here, the multiple hidden layers are there. So these hidden layers will increases the complexity. So the deep learning, where the deep refers to the multiple layers in the network. As you are keep on adding the multiple layers or the hidden layers are there, obviously that it may have the better output. But at the same time, as you can see over here, the deep learning is basically used over big data. Big data is different than the large data. When we talk about the quantum of data only, then it is called large data. But when we say a data is in abundance, data is of different type. I may have a patient record or 100 patients record. They have their laboratory data available. Then I have X-rays. Then I have CT scan. So I may have images, then laboratory test data. I may have ECG signal also. So for a single patient, if I have all these detail available, and for thousands of patients, I have such data available with me, and I wanted to process it to detect the disease. There I require deep learning. But if you have, for example, a single data set which is static in nature, data is in rest and data is in stream format. So when data is there and you wanted to process all the historical data, then it is not necessary every time to go with deep learning, right? Whenever you have manual feature selection is not there, then you may choose to go with deep learning where the data is big in nature, not in size, right? Big data means you have the volume of data is more, data is of different type, that is the variety of data is there, the data is available at a different pace from different sources, means at a different speed, so it has different velocity, and at a different velocity and data available not in a continuous or in a fixed form, so veracity is also there. So if you have these kind of data characteristics, then analysis is always difficult. So there you may think about deep learning and advanced deep learning models. Otherwise, whenever you have a single data set, abundant data set is available with you, right? If your purpose is served through machine learning models, then I recommend that you should continue with machine learning. And if required, then only you should go with deep neural network. And then going forward, when we say the third type that we generally discussing nowadays, it is I have a data available from different source. You can see now these data is available in text form, some video symbols are there, some graph symbols are there, some in audio data is there, images are available with me. The structured data is available to me, wherein the data is available in a structured form, rows and columns. I may have a data in document form. I may have a data in semi-structured form, in the form of XML also. So if data is available in XML or CSV file, such data are called semi-structured data, right? Comma separated values. That is what we call as CSV. So CSV is the semi-structured form. But if data is available clearly in row and column, the relational database, MS Access file, Oracle database, MySQL, all these are structured database. We may have sometimes data available because when we want to transfer the data, unstructured data will take less storage. The reason behind that is we are not supposed to send or transfer the schema of the database. We just have to send it in the form of text as a text file. So we may have NoSQL database like MongoDB. So we have such data available, right? And all these are unlabeled data. We have some model of we have applying some pre-training model, and we create one foundation model. These foundation model is used, it will be used for different tasks. So this is nothing but a simple way of understanding generative AI, right? So when we say GPT, where PT stands for pre-train, generative pre-train model. So the model is being trained over large set of vectors or a data points, and then a model is being created. So as you can see over here, the broad range of general tasks nowadays these models or large language models are performing are text generation. I will give you an example for that also, summarization, image generation, chatbot, question answering. All these are example of large language models. So, and we all are aware about the simple approach, like what is autocomplete, that when you start typing something in MS Word, right, or even in an email, right, and model predicts what your next word will be. So if I will write only ENGI, then automatically engineer or engineering will be displayed. So that is nothing but the autocomplete. It is not large language model. It is basically a simple code wherein it from the data point or the model will match the type words and corresponding uh, the next set of characters are being or the next set of uh, characters or alphabets of that words are displayed. But when we say that large language models predict the next sentence, not only it will autocomplete or it will complete the word, it will predict the next sentence, may predict the next paragraph, or even it may predict the next document. Now, all of you are using Chat GPT extensively, right? You simply write a leave note for so and so reason. So here you have given only one statement input and you will get one paragraph as an output, right? So here the model predicts the entire paragraph. Even if you write something that the that you want to study the explain different scheduling algorithms in operating system. You will get 2-3 page documents explaining all the scheduling algorithms. So here your input is only one statement. And these models are generating documents by understanding the context of your request. And it works in the reverse form also. If you give entire paragraph as an input, and if you write that summarize these in 2 lines, you will get summary also. So if you give entire email text as an input and ask generative AI model to suggest the title, then model will suggest title also for that, or subject line for the email. And if you give subject line, then it will provide you the subject, the content also. So that is what the power of large language model. So here, when we say large language model, these models are generating new content based on user request. And that is why the models are so powerful that it reduces the burden, it reduces the efforts that are put in by the individuals. Then we talk about audio models. Then we have example as a chatbot. All these are large language models. The outputs are different. The outputs are in the form of chatbot. When we say chat GPT, we may get the new content. Or even we may have audio models and video models. So nowadays you must have like received these kind of deep fakes videos wherein the audios are being embedded with the individual's videos, or not even embedded, right? It is like, so if you use this for advertisement purpose, then it is fine. But deep fakes are extensively being used, right, for the wrong purposes. So this is where the world is moving. Now, all these, what I have discussed right now, is called generative AI. But what I wanted to suggest, main thing, is the heart of all this model output is nothing but data. The unlabeled data that we have. You just imagine if data is not available, if there is no internet, how one should get the data? And if abundance data is not available, how the model is being trained over such humongous data? So this is what a classic image, that artificial intelligence turns single bullet point into a long email that I can pretend I wrote. So you just give a subject line to a chat GPT or any such pre-trained model, and then it will give you entire document or a paragraph for that statement. Or if you AI makes a single bullet point out of these long email, I can pretend I read. So rather than reading, if you wanted a digest of an entire document, you just supply that entire document as an input and ask model to summarize it into half a page, then the model will do that. So those who are like have done their PhDs 5, 7, 10 years back, they must be aware about the kind of text summarization and the set of algorithms we used to apply, wherein we have to think about the term frequency and inverse document frequency and all these things. And then at the end, we get some summary. And then we must have some ground golden truth available, right, with which we can compare the output and check the accuracy. All these are in applications nowadays. So whatever the kind of research or the research work that the people are doing, right, the outcome of all these research work or most of the research work is there in applications. So now let us come back to now towards the data. So the last slide here, the most important point when we talk about large language models, the foundation model is very, very important. And the input to this foundation model is data. And why these foundation models are available nowadays? And because of these reasons. That every day we create 2.5 quintillion bytes of data. Every day. Now, if this data is being stored or copied in a CD, right, then it requires 10 million. 10 million means 1 crore CDs, so which is equivalent to 4 Eiffel Tower site. So this much of data is being created every day on a digital platform or over internet. And the most important point is this one. 90% of the world's data today has been created in last 2 years alone. The reason to this is that those who are Gen Z, they are extensively using social media, right? Elderly people are not using social media, right, frequently, or they do not have enough knowledge about how to use it. What will happen after 10 years? Those who are not at all aware about how smartphone works, right? They will not alive, or most of them will not alive after 10-15 years. And you compare that the next 10 to 15 years, the user base for all these digital platforms are keep on increasing. And the emergence of large language models will attract more users over different applications. So 90% of world's data today has been created in the last 2 years alone. Now, out of these data, just imagine that some of the data is in private custody because they are sensitive data. But every day, if 2.5 quintillion bytes of data is being generated, and even 90% of these data is being created last 2 years, and if 50% or 40% is available in public domain, like all internets are open, right? You can access the information through different crawlers and fetch the information. So you can access any website. So data available over website are or any information available over website. I am not talking about the database, right? I'm not talking about the data servers being accessed, but the data that has been available over internet, available over different social media platforms. All such data is being available for public use for analysis purpose. Not only data, you have all YouTube videos available. YouTube videos are also a good source of information, good source of data. You have images available. You have all news sites available. You have data available for weather. You have data available for stock market. You have data available for public policy. You have data available for the judgment of different court cases. All such data are available. You have lots of information available about different medicines and drugs. So nowadays maybe the data is available in different form, but now data is available. And the most important point is this one. Out of all the data that we create, only 0.5% is analyzed and used. Only 0.5% of data that is being created is analyzed and used. Otherwise, we simply store data, and if something goes wrong, then we can retrieve the data. That is the only purpose by which most of the companies are archiving the data. They are not analyzing the data. And that is what makes the difference. That is where the developed countries are ahead of all the emerging markets. because they have that capability, processing capability and technology in place, which allows them to analyze such database. So this is classic data pyramid or a value pyramid. So data is the core for any analysis purpose. Without data, there is no analysis. Raise all our assumptions. And as you can see, the base is very large. So it means that when a data is available, enough data is required, right, for knowledge generation. As you can see, the width of this knowledge step is smaller than the width of the data step. So you can extract the knowledge if you have enough data is available. Now I will give you the example that how we should understand this value pyramid. Now you have data point, data available. Let us assume that you have a data wherein one data point is mentioning that milk. Second data point is mentioning that, say for example, lemon, right? So we can say that these are food items, right? So, but these are simple data points. Okay, now when I say milk and when I say lemon, so you may have think about these are milk and lemon are only data points. Now, when you say information about milk, you can have different features of that, the fat and all this. For lemon, you may have color and all, right? So that is information about the data. In a nutshell, if I say that if I will give you the marks of a particular subject, right, of entire class, so that is nothing but my data points. What kind of information you can retrieve from that data? What kind of information you can retrieve from that data? Hello. Suppose you have,
Yes, sir.
yeah, suppose
Yes,
you
sir.
have the marks of 60 students for a given subject. So these 60 marks of a 60 students are 60 data points. What kind of information you can access or you can get through this data?
Number of hello, sir.
Yeah, please go ahead.
Yeah, number of students were passed out of 60. Who got the number of percentage we also got from that.
Okay, fine. Then we can, what is the highest mark? What is the lowest mark? Okay, so the kind of information that we can get from these 60 students marks for a given subject, what is the highest mark, what is the average marks, the lowest mark, how many students pass this subject, how many students fail in the given subject, right? So this is nothing but an information. Now if I give you same students or if I give you same subjects previous 5 batch data, then you can have this information for 5 different years. Yes or no?
Yes, sir.
You can have mean of batch last year students for this subject, mean of the previous to previous year. You have the mean of the current batch of students for these the marks of a given subject. So all these are information. Now what kind of knowledge you can extract from this?
We can extract the
Yeah.
trend that
Yes.
now in the future year or in upcoming year, how many students will pass after analyzing 5 years of data.
Okay, so when you say that enough data is available,
That kind
again,
of knowledge we
earlier,
can get.
yes, earlier we have only 1 year of data available, right, from which we can get some information, but we cannot take any extract any knowledge out of it. If I will have more data available of a different period, I can have some relation that over the years the students' performance is being increased. Over the years, the number of students pass in these subjects are increased or decrease or remain same. Now, Imagine that you will be given one subject's 5 years marks of a one subject, and for same students another subject's marks. You can extract even more knowledge that the students who are good in subject 1 are most of the time good in subject 2 as well. So you can find out the correlation between these two subjects. Those who are good in, say for example, those who are good in mathematics, they are good in security also, because data security talks about modular arithmetic. So that kind of trend and relation you can find. Okay. Now, based on this knowledge, you will get the answer about why these students' performance is being decreased over the year, or what are the reasons by which the students' performance is being increased, or the mean result is being increased because the adoption of new pedagogy, or we may have students of higher merit compared to last year, or we may have their mathematics mark of plus 12 and then compare it with engineering marks. So over a period of time, we can have the answer regarding why this trend. So that is why the answer to why is nothing but an experience. And then wisdom. Sometimes what will happen that we take certain steps and it backfires. It is not like that we discuss something and then later on we found that the step or the action that we took was incorrect. So in future we will not repeat that. So that is nothing but wisdom. So alone data is of less important, as you can see over here, wherein knowledge experience is benefit to the humanity, and it is of more importance. Right. So data is simple symbol. For computer system, these data points are nothing but symbol, whether it is a color value or whether it is the age or it is a mark. For computer system, they are simply numbers. They are symbols. Right. The kind of answer that we can get, what is the average, what is the highest mark, how many students are, uh, 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 what are the sources of these data, these kind of information we can get through data. So the size of information is less. If I say I have 1,000 students data, I have 1,000 data points. And if I will find out some of the, extract some information, I may have mean of the number students. Only one data point is there. I may have how many students pass in the subjects. I may have another data numbers. So if I have 1,000 data points, I can have 15, 20 numbers to represent information about the data. Right. So now the next topic is about descriptive data and exploratory data. So as the name suggests, descriptive data means description about the data, a numerical approach to data analysis, what I have discussed just now. Mean, central tendency, correlation, all these are descriptive data. And visual approach to data analysis is called exploratory data analysis. Right? An image is equal to 1,000 words. Right? So if you present data in a proper way, so visual approach of data analysis is very, very important, right, for decision making for some of the applications. Now this is the classic Venn diagram, that descriptive data is all about what is happening. We just have to check whether the data is correct or not. How we should properly visualize the data. So sometimes these descriptive data is being clubbed with exploratory data analysis, or it is used for effective exploratory data analysis. Then we have diagnostic. So what is happening? What is the average? What is the mean value? What is the standard deviation? So this is nothing but description about the data. What is the central tendency? and how many students secure A grade, how many students secure B plus grade. So that is also a description, but the form is, or we are visualizing the data rather than providing it into the tabular form. Diagnostic analysis in the sense that why is it happening? So why is it happening is more about, so if you know the description of the data, then only you will be able to understand the kind of model that you should use to extract the reason or to get the reason behind the patterns. And then what is likely to happen once you train the model, that is diagnostic, and then test the model to get the accuracy of the data for any unknown data set, whether the model is able to predict properly or accurately or not. So that is the next phase that we call predictive. What is likely to happen? Choosing the right algorithm, building the right business strategies. So why lot many algorithms are available for machine learning? Why we should not have only one algorithm or few algorithms, right, which are applied over different data sets? So then we have perspective, that is using the advanced analytics, and that so recommendation systems, like if you buy something over any e-commerce platform, you will get the recommendations that those who buy this product, most of them have bought the other product as well. So these kind of recommendations are provided. So they are called prescriptive analysis, right? It is the prescription that the system is giving you. Now it is up to the user whether user want the other product or not. But this is what most of the users have done. And the last one is cognitive analytics. So that is more about behavioral. So in value proposition, cognitive analysis is always have the high value, and there comes prescriptive and predictive. Now, why is data description, or why the description of data important? Now, if I show you these two graphs, right? Now, both graphs you can straight away, these are visualization. This is again data description, but exploratory data analysis. Okay. Now, which one is the proper way to present the data? First of all, tell me whether these two graphs are same or different.
Same, sir.
Both are same, right? As you can see over here, the both graphs are of same data points. See, when you have values, right, which are very close to each other, then you should present them as it has been shown in the right side. Because showing all graphs of almost equal height does not serve the purpose. Here you can explain it in a better way. How much improvement is there as compared to, now you can see over here, your brand, right? Here you mentioned that your brand is still working fine, right, after 10 years. So it's the most of the more than 98% of cases, right, the brand is performing well after 10 years. While rest three cases, they are above 95, but way below 95, 98. So this is the correct way of visualizing the data. और यहाँ पर भी मैंने वही दिखाया है. In left side also I have shown the same numbers, but you cannot find out the difference. So whenever you present your work, whenever you are writing a paper, make sure that you should have proper visualization, proper explanation of your the result. So these, most of the time I have seen this, that the students or the scholars draw the graph, right, as I have drawn on the left side. This is not the way you should present your result. There is no interpretability. If I will give you only one table, or sorry, one graph that is on left hand side, and will ask you to explain or interpret the result, how you're going to interpret? But the same graph, if I will present, right, with different scale, right, well, you can see over here, then I will be able to justify, I will able to defend my work in a strong way, which was missing in the earlier case. Now, when we say, I'll quickly go through this, like descriptive statistics. The standards are central tendency. Central tendency in the sense that we say mean, median, and the mode. And then, sorry, and then we talk about the standard deviation and variance. So these are some of the cases, but these are applicable only to numerical data. So numbers that base represent the most typical score of frequency distribution are mean. That is what the arithmetic average of all scores. Why I have been discussing is because most of the time, without understanding the data description, the people have started applying, or people start applying models and algorithms over the data. So that is why I always emphasize that whatever data you are using, first understand the data. Data understanding is the most important task. Your algorithm or model selection is always based on the data. And if you understand the data in a better way, you will be able to choose best algorithm for the data set. Right? And that will give you better accuracy. So mean is always impacted by outliers. If one value is higher than the rest of the values, or way higher than the rest of the values, then obviously mean will be deviated. Median is the middle score. Suppose if I have 10 numbers, if I sort the numbers, right, the middle number is nothing but median. So it is not the average, it is the 50th percentile. 50th percentile means how many numbers, or 50 percentage are a percentage of numbers are greater than given number, and the rest numbers are less than the given number. So that is called median. But the median is found only after sorting. And mode is the most frequent distribution. There are applications wherein the mode is being used, mainly in the categorical data. Categorical data in the sense that if I have some, uh, like the attribute is color, right? And 7 different colors are there. Suppose the database is for regarding the car, how many cars were sold, right? So I have different color values. So mode indicate the most frequent score in a distribution of scores. So frequently, if white car is being sold for the with the maximum numbers, then the mode is nothing but the number which is corresponding to color white. So suppose if I have this score of some 10 students, and then their mean value, or sorry, these are the IQs of, or score of IQ for 10 students. The mean value is 114.6, median is 101, because the range is between 95 to 160. So
Sir,
as you
can you
can
just,
see over yeah,
sir,
yeah, please.
sir, can you just go to the previous slide and just explain, sir, mean, mode, and this one, three.
Yeah.
Uh,
So yeah, so I'll have that. So mean, median, and okay. So mean, so I'll have that slide here. So as you can see over here, that the income per family, this is the first case, first exercise, or first example. If you take sum of all the numbers, divide by the frequency, or divide by the total number of candidates, you will get the mean value. Okay, so in case 95 plus 98 plus 100, 100, 100, and then 160, divide by 10, you will get 114.6. Median is, as you can see over here, the numbers are even, or the number of candidates are even. So there is no central element. See, if there is no central element, then in that case, the average of two central element will be considered as the median. So the two central elements are 100 and 102, right? So their average is 101. So the median score of these 10 number is 101. Mean score of these 10 number is the sum of all 10 numbers divided by 10, because the total 10 candidates are there. So sum will be 1146 and divide by 10. So the mean value is 114.6, wherein median is the average of these two. Median you should calculate only after sorting all the numbers. If numbers are given unsorted, then in that case you have to sort the number first and then find out the median value. See, median in that way, many a time to avoid the outliers, median is being used. Now imagine what will happen if by mistake or for any reason, suppose this data is not of IQ data, it is the data is being collected through device, through sensor, and these data represent some numbers. And by mistake, because of malfunctioning of this device, the 160 is being recorded as 1600. So in that case, if the last value is being recorded as 1600, your entire mean will be shifted because of these 1600 numbers. But it will not change your median value. Because even if you have 1600, when you sort all these, your median will always be the average of 100 and 102. So median is not affected by outliers. Mean is always affected by the outliers. And when we say mode, mode is in a simple term, out of all these 10 numbers, which number is being reported frequently. As you can see, 100 is being reported frequently as compared to other numbers, then 100 is considered as the mode. So in these database or data points, 100 is mode, 101 is median, and 114.6 is the average or arithmetic mean of all the 10 numbers. Is it clear? Hello, is it clear?
Like it is like a middle value, no, sir? Median means it is like a middle value of the
Yeah.
set.
Median is the middle value after sorting the database. After
Now, yes,
yeah.
I got it, sir. Now, as you said, if it is some, like these are the data points obtained through some experiments or something, or you said some sensors, or through some image data we want to classify, like cancer cells or something.
Yeah. So
So
data points,
actually
first
that
thing is
outliers
you.
will be important, no, sir, in that case, because
Yes,
where there is
very important.
something abnormality, only you have to check.
Yeah, so see, when we talk about pre-processing techniques are important depending on the applications for which you are using the model or you are like processing the data. If you have the outliers or if your application is related to outlier analysis or anomaly detection, you should have outliers as it is in your data set. Okay. But if your
Yes, sir, that
application
is
is,
that is what I was.
yes,
That's right.
yes. So you should keep outliers because that is what you have to identify. The machine should the extract that information, right? Now, as you can see over here, the data point, this is another thing that we have the symbols are there and the income per family in thousands of dollars. Now, two families have 15,000 uh, uh, dollars income, right, per year. As you can see the first image. Then we have one family having $710,000 per year income. Now you can see the range 15 and 710. And then second last is 475. So if you multiply all these 20 into number of families and all the numbers, you will get the mean value as 70. But only 3 data points are above mean value. And you can see over here 1, 2, and then here 7. So you may have some 20 numbers less than 70. So data distribution is not proper. This will give you imbalanced data. Right? This will give you an idea about the imbalanced database. Most of the healthcare database are imbalanced because in healthcare database only 2 class labels are there, whether a person is having a disease or not. So naturally, the person, if the disease is critical, then less number of patients will have that disease, wherein most of the patients are having are not having that disease. So data is in healthcare for critical diseases. Data is always imbalanced. Now let us take an example of any cancer database. So cancer binary classification of any cancer database is having 2 class, benign or malignant. Benign means non-cancerous, malignant means cancerous. Now if I have 1000 patient data, obviously I have 50 patient having cancerous or having class value malignant. Rest 950 are having class value as benign. If I test my model, if I train my model with this data, obviously my model is biased towards, my model will be biased towards the benign data because more data points are of that class. So I need to add more data which are of malignant type, right? So that the model is not biased towards one particular class. Now with this figure also you can see that the mean value is 70, median is 30 and mode is 20. Now mode is very simple. You can see the frequency of people or a family for per year income or annual income $20,000, right, is there. So obviously the mode is the value for which highest frequency is there. Median is nothing but the central element of all the data points. So here you cannot say that 30 is the central element, but you have to take the total of all these numbers. Just a minute. Total of first, second, and third, and the total of all these. So this one is the median. And mean is always the arithmetic mean. Most of the families are having annual income less than mean. Generally, when we say mean is always the central tendency, represent the central tendency. But when the data is having such outliers, then the mean is always shift towards the outliers if the outliers are on the higher side. So how to remove the outliers? How to represent the outliers in exploratory data analysis, that I will discuss next. So this is where the impact of outliers is there in the mean. Whereas you will not find large difference in the outliers, large difference in the mean value in the first data set. Now, what is the measure of variability? Suppose how the data set is being varied. So the one important aspect that we should look into is the range. What is the range? Range you can see in these data, the range is 95 to 160. Here the range is 15 to 710. So that will give you indication about the measures of variability. Now suppose if I will ask you to plot the graph wherein one data point is age and the second data point is annual income, right? And age is between 25 to 50 and annual income is, right, is ranging from, for example, 5 lakh rupees per year to 25 lakh rupees per year. If I will ask you to draw line graph, then in that case, I will not be able to see the age value, because the age values are between 25 to 50 and the income value is between 5 lakh to 25 lakh. So I will not be able to draw two lines representing two different set of numbers. So if I wanted to find out the relation between these two, then what I should do is I will have to normalize the age value between 1 to 10. So 25 will have value 1, 50 will have value 10. So you can use min-max normalization, z-score normalization, any such normalization technique. Same way, I will normalize the value of annual income, wherein 5 lakh is having value 1 and 25 lakh is having value 10. Now I will have two different data points whose range is between 1 to 10. Age between 1 to 10, where 1 represent 25, 10 represent 50. Annual income, again between 1 to 10, where 1 represent 5 lakh and 25 and 10 represent 25 lakh. So I may have all values of age are 1, 2, 3, 4 up to 10, and same is the case for annual income. Now I can draw two lines, and if two lines are parallel, I can conclude, or almost parallel, I can conclude that as age increases, income increases. Otherwise, with the help of visualization, I will not be able to explain these phenomena. And this is for 10 numbers. Suppose if I have 1000 numbers and these 1000 data points are available with you, then it is impossible for you to find out any kind of correlation between two attributes. Correlation is another important aspect that you should know about the data. The standard deviation is the measure of the average difference between each of the values in a data set. So standard deviation means once we have a mean value, how all the values are away from the mean. That will give you standard deviation. So suppose if I have if I have the values like 1, 2, and 3, right? Three values are there. What is the average of three values? When I say three numbers, 1, 2, and 3, what is the average of it?
2.
Hello? So the average of these is 2. Okay? Now, the another three values that I can give, like for example, the three values are 10, minus 8, and 4. What is the average of it? 10, minus 8, and 4. What is the average of? So here also the average is 2. So it means that both data points are having same mean value, means they are same. So most of the time, mean does not provide you clear idea about the data range or data variation or deviation in the data. Now, when you say that the average of 1 to 3 is 2, all the values are near to average, right? When we say 1 is 1, 2, and 3, so the values are nearer to mean value. Wherein when I say 10, minus 8, and 4, the values are away from mean. So the values are deviating from mean in the second case, wherein in the first case, values are nearer to that. So even in a class, right, if all the students, if the average marks is 60, and if the most students are having marks between 55 and 65, it means less deviation is there. If average is 60 and students have a marks between 30 to, most of the students have a marks between 30 to 90, it means deviation is more. So how far each data point is away from, or sorry, how far these each data points are from mean, that will give you the idea about standard deviation. So this is what standard deviation is all about. As you can see over here in the middle graph, right, when you have Gaussian distribution like this, your mean value, right, and the deviation represent the values are widespread. Here in the middle one, most values are around mean. These are very small values on the either side of these graph. In the first graph, these mean and one level of deviation, second level of deviation, and third level of deviation. What is means? Now you can see these numbers are there. The standard deviation I have calculated. All these scores are 10. These are some 8 students score, and their mean is 80. Here also mean is 80. But the score is between 60 to 100. Here scores are between 70 to 87. So here the mean value is 80 and the values are -8 and +7. Here mean is 80, but values are -20 and +20. So these scores are more deviated from mean, and the first case is having less deviation. So that deviation you can find with this, the standard formula. The deviation degree is only 5. In second, it is 15.8. Larger the deviation, the data is more sparse. So when you say the standard deviation value is high, it means data set is sparse in nature. When standard deviation of a given attribute value is less, then your data points are dense in nature. Okay, so this is how we generally represent the data points, the numerical data points. Now this is very important, that most of the time you have some mean value and 68.2, these are standard numbers. 68.2% of numbers are always between +1 and -1 standard deviation. So your mean value and your standard deviation. So here you can see your mean value is 80. In the first case, standard deviation is 5. So these indicates that your 68% of values are in the range of 75 to 85. These are standards. This is 80. As you can see here in the first table, left side, mean value is 80 and deviation is 5. So the deviation, standard deviation suggests that ±1 standard deviation. One standard deviation matlab 5. So 68.2% of numbers are always in the range of 80 plus 5 and 80 minus 5. Here in this case, 68.2% of values out of all 8 values, if I say 10 values, then 7 values are in the range of ±1. So here deviation is 15.8, almost 16. So -16 and +16. +16 is 96, -16 is 64. So 68.2% of values are in the range of 64 and 96 from a given database. If I will have -2, means the standard deviation is 5 and mean is 80, 2 standard deviation matlab 2 into 5. Now I can say 95.4% of my values will always be in the range 70 and 90, because my mean value was 80. So 70 means 5 was mean. So 2 into 5 is 10. So 70 and 90, my 95.54% values are always in this range. And almost 100% values, bearing 1 or 2 values when your data set is large enough. Only 3 points out of 1000, when I say 99.7 plus or minus 3 standard deviation, only 3 out of 1000 numbers are left to -3 and right to +3. Total 3 points out of 1000. Rest all are beneath this. Now, if you do not have these bell-shaped curve like this, and you have more data variation, like in example of first one, then obviously your deviation value will be more. So mean plus 1D and mean plus -1 deviation will have the more stretch over here, wherein here you will find out the less area will be covered, but the height is more. So how much time is remaining? Hello? Hello?
Hello.
Yeah.
Yes, sir. Yeah,
I think
time
it is.
was till 9. Yeah.
Okay, so it
Sure.
is
But
almost
if you
over.
want,
So
you can continue, sir. Yeah.
I'll take 5-10 minutes because I have more slides, but I will stop at a proper place. So okay. So this is what the correlation is all about. As you can see over here, this indicates the positive correlation. The positive correlation means age and income hopefully has a positive correlation. As I mentioned, as age increases, income increases. So you may have these kind of graph, or you may have negative correlation also. If one value increases, the other value is always decreasing, then it is linear correlation, right? So negative correlation means the variable go in opposite direction. Age and immunity probably has a negative relation. Suppose immunity has some number, right? So when your age increases, obviously your immunity level is decreasing most of the time, right? So that is what the correlation is all about. And then this is again curvilinear correlation. Data points are there and points are above and below. Equal number of points are there above and below. This is called strong relation. Points are nearer to the central line, more nearer. In the first case, they are away, but the total distance of all the points which are below this line, trend line, and which are above the trend line, their squared distance are same. Here also squared distance are same, but they are more nearer to the central tendency or trend line. Here, very weak correlation. Relationship is there. When one is increasing, the other one is increasing, but the correlation is very less, very weak. And you can see over here that there is no relation. Why? Because the trend line is straight. We cannot say that as X increases, Y is increasing or decreasing. So there is no relation. So I will show you the one important the regression or correlation mechanism. Right? Is my screen visible? This is the last exercise that I just wanted to explain. Hello?
No, sir.
Yes, sir.
Excel, I have shared one Excel sheet. Just a minute, I need to unshare and share again. Now, is it visible?
Yes, sir. Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
sir.
Now these are simple 10 numbers I have given. Now if I give you these 10 numbers, what kind of trends you can see from these numbers? Do you have any kind of trends? Like as X increases, Y also increases, nothing like that, right? But how you are going to explain this? I have given you only 10 numbers. What if you have some 120, 100, 200, 500, 5,000 numbers? So let me show you that how we can check this. Suppose if I have these two numbers, first what I should do is I will plot these numbers as a scattered plot. So all these numbers are there. As you can see, first
Hello, sir.
the yes, is it?
Some sequence is there for
Yeah,
yeah.
yeah.
So
And I wanted to
yeah, for
analyze this sequence. Right. I wanted to analyze this sequence. Okay. Now what I have done is I plot these data points on a scatter graph. So you can straight away select these. So this has, like, I have select the range X and Y, right? Not the total, right? These are the data points. Then I select this. So the code is also available, right? In Python also, you can straight away write this equation. I will show you this, why I have written the slope and intercept also. Now, as you can see over here, these are all data points. If I click on any of these data point, you can see that this is nothing but the first data point, 0 and 2. Just a minute. So I have these as 0, 2. Then I have another value 1 and 34. Then this one is 2 and 12. Likewise. So I have plotted all these numbers. So these numbers are away from any of the trend lines. Suppose if I wanted to draw a straight line to represent all these points. Okay. So what I should do is I will add the trend line, right? The linear trend line. Okay. Now you can see over here, the trend line is being drawn. Now this trend line indicates the distance or the squared distance of the point which are below this trend line, and the sum of squared distance of the points which are above this trend line are same. It means that if I will take sum of the distance between the points which are above the trend line and sum of the distance between these points below the trend lines, then both sum are equal. That is where the trend line is drawn. Now there is a formula. Now if I want suppose if I draw a simple straight line, then obviously all straight line E can be represented using y equal to mx plus c line. So let me write the equation for this trend line, right? So now you can see over here, the equation is y is equal to 7.1333x plus 12.2. It means y is equal to mx plus c, where value of m is equal to 7.133 and value of slope intercept, that is c, is 12.2. So the calculation, if you wanted to calculate these or without graph, if you do not have this facility available, and if you want to write a program and draw the graph on your own, you can use this equation. So slope is nothing but n matlab kya? How many values are there? Right, total 10 values, n represent values. Sum of xy matlab, first I should have in x and y, and then after that I will take sum of all these. So this is what the sum value I have. So 0 into 2 is 0, 1 into 34 is 34. Likewise, I have calculated x into y. And this value 2582 is nothing but sum of x into y. Now I have sum of x into y available. N is also known. What is sum of x? Sum of x I already have 45. Sum of y is 443. So I have n value available, sum xy available, sum of x is available, sum of y is available. Sum of x is available. So these sum of x whole square is also I can calculate. The only thing I do not have here also I use sum of x. The only point that I do not have is x square. So what I have done is I have calculated x square. Okay. So x is 0. So square is 0. X is 2. Square is 4. X is 7. Square is 49. Likewise, I have calculated all this. Once I will put all these values into this equation, I will get the value 7.13 as m. Once m is available, I will use that value of m over here and I will get the value of c here. Now, this I have calculated with the equation. You can see over here 7.1333x plus 12.2. So this is m, c. So same is written over here. Y is equal to mx plus c. But the points are away from it. Now you can see over here, the points are far away from the trend line. So that will be measured with the help of R squared values. What is the R square value? 0.3855. Now I do not need these numbers. I just wanted to stick to this graph only. So I will change the color so that you will not be confused. I just wanted to highlight that how these will work. Now let us assume that I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because the value of x is increasing. Let me write these numbers, right, in an increasing fashion. 12, but they are not linearly increasing like 0 to 1 and 1 to 2, but increment is only 12 to 14. Then I have 18. You can see over here, your R square value and equation is also changing. Lower the value, points are away from trend line. Higher the value of R square, points are nearer to trend line. Right? Suppose now I will write 22. See the value 0.53. The value of R square is between 0 and 1. Because when you take square, minus is not possible. So the highest value is 1. Suppose 22, then 25. 59. Right? Then I have 29. Then we have 33. Then 36. And then 38. See the value of R square. 0.97. And the points are almost on the line. Right? Almost on the line. The first value is 0 to 2. Suppose because the value is 0.97, what if I will change value of y from 2 to 10? What will happen? Suppose if I change this value of 2 from 2 to 10, then hello.
Yes, sir. It is almost 1.
So it is almost 1, right? As you can see, 0.9934. So this will give you an idea about that how these numbers or the data points are correlated. These represent strong correlation, where the earlier case was representing weak correlation. Now I have 10 points only, right? Suppose if I want to extrapolate this, right? I want in forward direction, what if the value of x is 10 and 11? So I want, just a minute. So I want these two forward. Just a minute. Okay, so you can see over here, my last point is here. But if I go for two more points, if it is 10 and 11, it will follow this. So if I will have intersection of 10 and this, I will get some number, and that number is nothing but the possible value of y. This is how actually prediction happens. Right? This is a simple linear regression representing correlations. Right? So I think I should stop here. Yeah, any question? Hello? Any question?
No, sir.
Yeah, thank you all. Hello? Yeah.
Yes, sir. Thank you so
Yes,
much, sir,
Meenal.
for the
I am done.
session.
Yeah.
Yes,
Thank you.
sir. Sir, your topics are, you gave some examples and which is related to my research. I'm working on a model for student performance prediction itself. So you highlighted the importance of a diagnostic and descriptive analysis technique, which I can combine with my prediction model to make the predictions more timely and effective. And so this will definitely help me in my research, sir. Thank you so much for the session.
Yeah, thank you. Thank you all. So if any of you have any question, you can reach out to me, right? So on my email ID, that I'll share the presentation deck also so that you can circulate among the uh, the members as well.
Yes, sir, definitely.
Yeah, any
Thank
question,
you.
Ankit? Yes?
I had written it in the chat.
What you have written? I'm not able to see anything, Ankit.
Uh, yes, Ankit, sir, is it like you have asked what visualization techniques, strategies best reveal the hidden patterns during EDA
So
in
that
form?
so what some of the topics that I am not able to cover, but it is there in my presentation. So I will share entire presentation right with the coordinator, and I request coordinator to share with all the members, or you can have one shared folder and copy this presentation over there, and they can access. And there I'll have my email ID also. So if any of you have any query or any help required, then you can reach out to me. Right?
Yes, sir. Okay, sir. Thank you for the session.
Yeah. Thank you all.
Thank you, sir.
Thank you.
Thank you, sir. Thank you.
Thank you. Thank you all. Thank you.
Thank you, sir. It was wonderful session.
Yeah. Thank you all. Thank you.
Okay. And for the participants, if you have any other questions, you can ask in the WhatsApp group or you can ask here in the chat. We will try to answer them. And if you require experts' opinion, then we will forward it to them. And any other questions regarding to FDP or sessions of today's session, then you can forward in the WhatsApp group. We will answer you there. So does anyone has any other thing or query for today? Okay. Okay, guys, then we will officially end the today's session here. Thank you everyone for the joining, and I'll see you tomorrow.